Hello, everyone. I'm Dr. An. Pandas is one of the most popular Python data manipulation and analysis libraries and is fundamental to machine learning. This module will cover all you need to know about Pandas, which allows you to start immediately by performing machine learning and artificial intelligence tasks. Let's dive into the Python programming tutorial right away. Hello, everyone. I'm Dr. An. Let's dive into Pandas basics for machine learning. First, let's import Pandas. We can import Pandas using the import command import pandas as PD so that later on we can call pandas PD. Let's create some series first. First, let's create a series by specifying values in a dictionary format. Series is just a rank 1 array with access labels in Pandas. So here we created this dictionary serving as the argument for the Panda Series command. And in the dictionary, we have three key value pairs, A as the key and 1 as the value, B as the key and 2 as the value, and C as the other key and 3 as its corresponding value. And then you can see that we've created a Panda series, a rank 1 array with just a single column taking values 1, 2, and 3, and their corresponding indexes as A, B, and C. We can also create a Panda series from a list. So you only need to provide a list here with 3 values, 1, 2, and 3 as the argument for the Panda series. And then you will see that the Panda series is created with a single column with values 1, 2, and 3 because we did not specify the values for the indexes for the series. Therefore, by default, Panda series take value 0, 1, 2 as the indexes. And you can also specify the values for the indexes for series. For example, here we create a Panda series by providing a list as well as the corresponding values for the argument index. And as you can see here, the output is a Panda series, is rank 1 array with A, B, and C corresponding to the index values. And now let's create a Pandas data frame. So the data frame in Pandas, you could consider it as a rank 2 array with row labels. So here, the first way to create a Pandas data frame is by specifying values for each column in a dictionary format. For example, here we use the data frame function, and we provide the first argument as a dictionary. The first key in the dictionary is A. Corresponding values is specified in an index and in a list, and the second key is B. Corresponding value is also a list, and then key C and its corresponding values in the list. We can also optionally specify the values for the index. If we do not specify the index, the default index will start from 0. So it's going to be 0, 1, and 2. So here we explicitly define a list of values for the indexes. And if you take a look of the created data frame, the data frame has 3 columns named A, B, and C, and 3 rows with corresponding indexes of 1, 2, and 3. The second way to create a data frame is to specify values for each row in a list format. For example, here, the first argument for the Pandas data frame function is a rank 2 array, or basically a list of lists. So the list has 3 rows and 3 columns. The first row takes the values 4, 7, 10. The second row takes the values of 5, 8, 11. And the third row takes the value of 6, 9, and 12. We can also optionally provide the values in the list for the indexes of the data frame. And we can also optionally provide the column names A, B, and C. So therefore, the resulting data frame has 3 columns named A, B, and C, and also 3 indexes, 1, 2, and 3, corresponding to the 3 rows of the data frame. Now let's take a look at how we can reshape a data frame. So reshaping data frame from wide format to long format and vice versa is a very common data manipulation procedure. First, let's take a look of how we can use the melt function in Pandas to transfer wide data to long format data. First, let's create some wide format data frame. Here, we create a data frame with 4 columns. The first column is named student and consists of a list of student names, Andy, Bernie, Cindy, and Deb. And the second column is named English with their hypothetical grades in English class. And the third column is named math with their corresponding grades in math. And the final column is named physics with corresponding grades for their physics class. If we take a look of the created data frame, wide formatted data frame, we will see that we have 4 columns, student, English, math, and physics. And the 3 columns, English, math, physics, refer to the student's hypothetical grade that received from the corresponding courses. And then our goal is to transfer the wide data frame into a long data frame looking like this. So here we have first column student name. The second column is called class, consisting of 3 types of classes, English, math, and physics. And the third column is grade, consisting of each individual's grade for a specific class. So this is what we mean by a long form data. But how can we do the transformation from wide to long form? Well, there are different ways we can do that. The first way is to use the melt command. So in the melt command, we need to provide 3 arguments. The first argument is for the ID variable, denoting, in this case, the student ID or student name. And the second variable, the argument is called var name. Here you need to provide a new variable name for different categories. So here the categories are the 3 courses or classes the student have taken in English, math, and physics. And the final argument is called value name. And you also need to provide a new variable name for that for different values. So here, the different values refer to the different numerical grades that the student receive from each type of class. So if you use the melt command by specifying the 3 arguments for ID variable, var name and value name, the resulting data frame is in long form. Basically, it's the form that you've seen just before. And if you want to say you have a long form data and you want to transform the long form data to wide data, the first way you can do that is to use the pivot command. So pivot will stand for pivot table, and you are given with a long form data look like this. And then you need to specify, again, 3 arguments. The first argument is index, denoting the student name or student ID. And the second argument is columns, where you specify the categories, in this case, the different classes the student have taken. And the third argument is values, where you specify the values of those categories, in this case, student grade received from each class. As you can see, by using the pivot function on the long format data, the data has been transformed back from long format to wide format. The second way to transform long format data to wide format data is to use the pivot table. And the corresponding arguments are exactly the same as using the pivot command. You need to provide the argument for index, columns, and values. And using the pivot underscore table command, you will get exactly the same results as if using the pivot command, so that the long format data is transformed back to wide format data. Another way for you to transform wide data frame into a long format is to use the stack command. So in this case, the stack command is going to convert your data frame into a long series. Remember, Panda series is a rank 1 array because it's only 1 column. And let's see how we can do that. First, we start with the wide format data frame, look like this. And first, we need to set the index using student names by using the command setIndex. SetIndex is going to replace the generic index starting from 0, so 0, 1, 2, 3, into an index using the student names. And after that, you just need to specify the stack command. So let's take a look of the resulting data Panda series. As you can see here, the data has been in the long format, but it looks a little bit different than the previous long format we created using the pivot and pivot table. That is because the pivot and pivot table created another data frame out of the wide data frame, whereas the stack command actually created a Panda series with only a single column of the students' numerical grades. And then at the same time, it's also created a so-called multi-index because it uses a combination between student name and their class name as the index. So here, for example, the grade 10 corresponding to a multi-index and the English, and the grade 20 correspond to a multi-index of ND math. And here, for example, the 10,000 correspond to a multi-index of DAB English. If you want to unstack a long series into a wide data frame, you can simply use the unstack command. You do not need to provide any argument for the unstack command because unstack automatically recognizes that you have a multi-index and is going to unstack the the Pandas long series into a wide data frame utilizing the information from the multi-index. So as you can see, using the nstack command, you have transformed the long series back into a wide data frame. You can append two data frames by rows or by columns. So first, let's take a look at how you append the rows of two data frames. There are various ways you can do that. So first, let's create two data frames. So we create the first data frame called df1, and then the second data frame df2, and they look like this. So both data frames have the same number of columns, and named the columns share the same name. So both data frame have 3 columns, A, B, and C. And we can append the two data frame vertically, basically stack one data frame on top of another data frame using the Pandas concat command. So the Pandas concat command works similarly as the NumPy's concatenate command. By default, it is going to append to two data frames vertically. So you have the df1 on top, and then the df2 data frame at the bottom. And so let's take a look of the results from the concat command. Here, you have created a vertical concatenation of these two data frames. The first data frame, df1, is at the top, and then the df2 data frame is at the bottom. You can also append the two data frames horizontally, basically along the column, so that df1 is to the left and df2 is to the right. So because you are appending the two data frames along the columns, therefore you need to specify axis equals 1 in the Pandas concat command. As you can see, the result is a data frame with 6 columns and 3 rows. This may be confusing to you because in other statistical languages such as R or Stata, they do not allow the same column name in the same data frame. But in fact, the same column name can be used in the same data frame in Pandas. But this is not recommended because it could be quite confusing if you refer to a specific column name. And then a better practice is to have different column names in the same data frame. You can sort the values of a column in the data frame using the sort values command. You need to provide the column name, so based on which column you are going to sort the data frame. And by default, the data frame is going to be sorted based on the ascending order of the column name. So the resulting data frame look like this because the column A is used to sort the data frame in the ascending order so that the smallest value for A start first and then the largest value of A stay at the bottom. You can also sort the data frame based on a specific column using its descending order. You just need to provide an additional argument ascending equals false. And as you can see, the resulting data frame is sorted based on the descending order of the column value A. You can also sort the data frame based on its index. you need to use the command sort underscore index, and then it's going to sort based on the ascending order of the indexes. Sometimes you want to reset the index of the data frame. So here, for example, you use the reset underscore index to reset the index of the data frame. What the reset index is doing are two parts. First is going to create a new column called index, and that new column index is going to contain the values of the data frame's previous index. Because the previous data frame's index have values 1, 2, 3, now you could see that the column index value takes 1, 2, 3. And the second part of the reset index is to use the default index for the data frame. The default index for data frame start with 0 and take integer values 0, 1, and 2. If you want to rename column or columns of the data frame, you can use the function rename. And in the rename function, you need to provide the arguments for columns in a format of a dictionary. So in the dictionary, the key is the old variable name, column name, and the values are the new column name to replace the old column name with. So here, for example, we want to replace the old column name A, lowercase a with uppercase A, and also replace the old column name lowercase b with uppercase b, so that the resulting data frame have replaced the old column names lowercase a and b with uppercase a and b respectively. Because we did not specify a new column name for lowercase column c, so therefore that column name is unchanged. You can drop columns from a data frame simply using the drop command. In the argument, you need to provide the column names that you want to drop. In this case, we want to drop columns A and B, so we specify A and B in a list. As you can see, the resulting data frame has columns A and B dropped, and is only left with column C. You can drop missing values of a column in a data frame. So here, we created a data frame with missing values. And data frame look like this. All the values for the first row are intact, but there is a single missing value formatted in as the numpy NaN value. It is a missing value for the second row for column B. And you can drop the entire row with the missing value in column B by using the drop NA command. In the drop NA command, you need to provide the argument for subset because you want to drop the missing value corresponding to the column B. So therefore, you need to provide column B as the column name. And the resulting data frame would have that entire row corresponding to the missing value dropped. So essentially, drop NA is going to perform a list-wise deletion pertaining to the missing value for a specific column. Sometimes instead of dropping missing values, you want to replace missing values in the data frame. And you can easily do that using the replace command. So here you want to replace all the numpy NaN missing values with 0. And the resulting data frame would replace that missing value with 0. And sometimes you may have the need to fill missing values by some descriptive statistics pertaining to a particular column. For example, here you first create a variable that takes the median value of the column B of the data frame. And then you can use the fill NA command to fill the missing value in column B with that median value. So here I use a shortcut. I specify the argument in place equals true, so that it's going to fill the missing value with the median value in place. In place just means it's going to directly perform that operation, filling the missing value with median, and save that to the column B in the original data frame. If you do not specify in place equals true, the default is in place equals false. But if you want to achieve the same effect, you want to change the column B values in the original data frame, you can specify like this. So this command would have the very same effect as using in place equals true. And as you can see, the resulting data frame has the value NaN replaced by the median of the column B, which equals 5. Now let's take a look how we can subset observations in a data frame. So here, let's consider this data frame with 3 columns, A, B, and C. And we only want to reserve the observations in the data frame as long as the values for column A is greater than or equal to 5. We can achieve that simply by providing, doing this Boolean testing. So essentially what it's doing is it's going to compare each value in the column A in the data frame with 5. And if this condition hold, it's going to keep that row. Otherwise, it's going to remove that row. So therefore, because 4 is less than 5, so the first row is not selected. And 5 and 6 all satisfy the condition that is greater or equal to 5. So therefore, the resulting data frame take only 2 rows, and because the first row does not satisfy the condition, so it is dropped. Now, sometimes we don't want to drop the rows, but simply we want to replace the row with missing values if the condition is not satisfied. We can use the where command to do that. So in this example, we still specify the very same condition. We are testing each value in the column A of the data frame, whether it is greater than or equal to 5. If this condition is true, it's just going to provide the cell values. But if this condition is not satisfied, we are going to replace the values in that row with missing values. And sometimes if you want to replace the observation, the cells in the observation that the condition is not satisfied with a specific value instead of missing value, you just need to provide whatever value you want to replace the missing value with in the second argument for where. So in this case, instead of setting missing values for the row where the condition is not satisfied, you replace the missing value with minus 999. Sometimes you need to remove duplicate rows from your data before you feed the data into your model. So for example, we created a data frame with a duplicate row. As you can see that the values for the first row and the value for the third row are completely the same. So therefore, we have a duplicate record in the data frame. And we can check whether we have duplicated rows by using the duplicated command. As you can see, what the command is doing is it's going to test row by row to see whether any row or rows share exactly the same values. So of course, when it's testing the first row has no duplication. And then it's testing the second row, still no duplication, so both return false. But when it comes to the third row, it compared the third row with the first row and find out that third row takes exactly the same values as the first row, so therefore a true is returned. You can also remove the duplicate row or rows by using the drop duplicate command. As you can see, the resulting data frame have only 2 rows because the third row is dropped because it is a duplicate of the first row. You can select the first n rows by using the head command. So here I select 2 of the first 2 rows from the data frame. You can also select the last n rows by using the tail command. So here I've selected the last 2 rows of the data frame. You can also randomly pick a fraction of rows by using the sample command. In the sample command, you can specify a frac argument standing for fraction, and then you provide a proportion. So the proportion must be from the range of 0 and 1. And so, for example, here I want to randomly select 50% of the data of the observations from the data frame. So therefore, I specify frac equals 0.5, and it's going to randomly select half of the observations from the data frame. If you want to randomly select n rows, you can use the sample command, but with the argument n equals 2 in this case, so that I'm going to randomly select 2 rows out of all the rows from the data frame. You can select and order the top n observations using the n largest command. So here I'm going to select the largest column, the largest observation, and also I want to select the column B. So what it's doing is going to take the observation, a single observation where the values for the column B is the largest. So as you can see here, because the largest value for column B is 9, so therefore the column 6, 9, 12 is returned. By the same token, we can also select and order the bottom n observations using the n smallest command. So here, because the smallest value for column B is 7, so therefore the row of 4, 7, 10 is returned. We can subset columns, and there are different ways to do that. So for example, we can select a single column by the column name. We just need to use this hard bracket, and inside the bracket will provide a column name as a string variable. And the second option is to use the attribute using the df.a to select the column A in the data frame. So this is because in the data frame, each column is considered as an attribute of the data frame. So both ways would give you the column A from the data frame. You can select multiple columns with specific names using a list. So here I'm selecting columns A and C from the data frame. If you can also select columns using a regular expression or regex. So this is very useful if you have a really large number of columns and you want to find the columns whose name follow a specific pattern. Here, for example, we use the filter command, and in the filter command, we provide the argument for regex, standing for regular expression. And here in the string, you need to specify the patterns for the regex. So here in this toy example, I'm going to use this symbol. This denotes the start of a string. And then I want all the names, all the column names that start with A. And this $sign means the end of a string. So what essentially means that I only want to find column name that is a lowercase a. Of course, in reality, you should have more complicated regex patterns if you want to select a number of columns following a specific pattern. So this is only a toy example. And as you can see, the resulting data frame has only one column, column A selected. You can also use the query command to select rows based on a specific condition, very much like database manipulations commands such as SQL. In the query, you specify the condition in a string. So here I want to select all the rows that satisfy the condition that the value corresponding to the column A must be less than 6. So in this case, the resulting data frame has 2 rows because only in these 2 rows, the value for A, which is 4 and 5, both satisfy the condition of A less than 6. Whereas the third row is not selected because the third row has a value of A equal to 6. And now let's talk about label-based position and integer-based position. This potentially is a confusing topic for new learners of Pandas. So the label-based positions is called loc, L-O-C, whereas the integer-based position is called ILOC. Both are the ways that you select or slice a data frame. So let's first illustrate how to use the label-based position to slice a data frame. So the label-based position, the label simply means name, a column name or row index, or row name. And here we want to first choose all the rows, but we only want to get from column A to column C. Well, this is a toy example because the data frame only contains 3 columns, A, B, and C. But just imagine that this data frame has more columns, and we are only interested in the columns A to C. We can use the label-based position, the loc command to do that. First, we need to specify the rows because we are interested in all rows. We specify like this. And after comma, we want to select the columns because the label-based position required column names. So therefore, we specify column names here from A to C. And then, as you can see, the resulting data frame have all three columns from A, B, and C. So here, one caveat is you probably still remember that the Python has a tradition of last position exclusive. So you may think that now let's take a look at how we can utilize the integer-based position ILOC iloc. So instead of providing the labels, basically column and row names, the integer-based position requires that we provide the indexes instead. So for example, here we want to use the iloc and we provide all the rows. And we also need to specify in the list of the column indexes. Remember, the columns indexes also start from 0. So therefore, column indexes 1 and 2 correspond to column B and C. So therefore, the resulting data frame take all the rows, but only include columns B and C, because B correspond to the index position of 1 and C correspond to the column index position of 2. And we can also select the second and third rows by just the corresponding cell are going to return the value of false. Now let's talk about logic in Python and Pandas. Let's first create two data frames, df1 and df2. As you can see, the df1 and df2 share the same column names, A, B, and C. If we say df1 is not equals to df2, what this is doing is that it's going to test cell by cell whether this condition is true or false. If the condition is true, it's going to return true. Otherwise, it's going to return false. As you can see that because none of the cells in df1 is equals to the cells in df2, so therefore all the cells return the value of true. We can use the isIn to test group membership for a data frame. For example, here, let's take a look of the column A in the data frame, which takes three values, 4, 5, and 6. And I want to test whether in any value in the column A, whether that value is in the list of 4 and 5. So essentially, what this is doing is going to test cell by cell whether the value A is in this list. Because 4 is in the list of 4 and 5, so it returns true. 5 also is in the list of 4 and 5, so it returns true. But 6 is not, so therefore false is returned. We can use isNull function to testing missing values in a data frame. So for example, here we created a data frame with one missing value here in column B in the second row. And we use the PD is now function to test this data frame, and it's going to test cell by cell whether there's any missing value. If there's missing value, it's going to return true. Otherwise, it's going to return false. And as you can see, we have a single true here because the corresponding cell is a NumPy missing value. By the same token, we can also test non-missing values. As you can see, all the other cells in the data frame return true because they are not missing value. And the only missing value here returned a value of false. Now let's take a look at how we can summarize data using Pandas. We can first count the number of rows with each unique value of a variable using the value underscore counts function. So here, the resulting data frame, there is only 1 4, and there's only 1 5, and there's only 1 6 in the column A of this data frame. So the corresponding counts together with the unique values are reported. We can know the number of rows, basically the number of observations of a data frame using the len command. So len data frame is going to return the total number of rows in the data frame. And we can also report the distinct values in a particular column of a data frame using the unique function. So here, the output is an array containing all 3 unique values in the column A of the data frame. They are 4, 5, and 6. We can use the describe command to report the basic descriptive statistics for all the numerical columns in a data frame. And those descriptive statistics by default are a count of the non-missing values in all the columns, their corresponding means, standard deviations, minimum value, 25th percentile, 50th percentile, basically this is the median, and 75th percentile, and also the maximum value for each of the columns in a data frame. So one caveat here is that describe is only going to work on the descriptive statistics for the numerical columns. So if one or more columns contain non-numerical values, then the describe command will not work on those columns. You can sum the values of each column or each row in the data frame. So here we use the sum command and providing the argument axis equals 0 to denote that now we are going to work along the rows vertically so that the sum axis equals 0 is going to calculate the column sum. And now if you take a look, so this is the original data frame, and we use sum axis equals 0 to calculate the sum for each column, so that the first column, column A, we have 4 plus 5 plus 6, so you get 15. And for the second column, we have 7, 8, and 9, so you get a sum of 24, etc. If you want to sum the values for each row in the data frame, you should specify axis equals 1, because axis equals 1 means that you are going to go along the column. And the corresponding results look like this. So for example, in the first row, you calculate 4 plus 7 plus 10 so that you get the sum of 21. For the second row, you have 5, 8, and 11. You sum them up and you get 24, etc. You can count the number of non-missing, basically non-null values of each column using count. And as you can see, there's no missing values. So for column A, you have 3 net missing values. Column B, 3 net missing values. Column C, also 3 net missing values. You can report the contiles, arbitrary contiles for each column by just specifying what percentile you try to calculate. So here, I want to calculate for all the numerical columns, the percentile, the 25th percentile, the 50th percentile, and the 75th percentile. So the corresponding values of those percentiles are reported for each of the columns. You can also calculate the mean, the median, the maximum, minimum variance, and also standard deviation for each column in a data frame. They are very self-explanatory, so we do not talk too much about them here. A very useful function in Pandas is the apply function. So you can apply a function, either a built-in function or a self-written function for each of the rows or for each of the columns in a data frame. So here I'm applying the built-in function, which is a numpy sum function to each of the columns. Remember, for each of column means that you are doing the calculation along the rows. So the axis equals 0, meaning that you are going to calculate the sum for each column of the data frame. And axis equals 0 is the default for the apply function, so that you won't have to have that argument. And as you can see, the resulting data frame is the sum of column A and also column B and C respectively. And you can also supply a self-written function to the apply function. So here I specified a simple one-liner function, the lambda function. I want to, for each column, I want to calculate the maximum value of the column and then minus the specific value in that column. So if we take a look of the results here, for example, for the first column, column A, the maximum value of that column is 6. So essentially, it's going to, the function is going to use 6 minus the corresponding value of A, in this case 4, so you get value 2. And then you use also 6 minus 5, so you get 1. And finally, you have 6 minus 6, you get 0. So this is how you can use self-written function in the apply command. You can make new columns and also do computation based on the existing columns fairly easily. So here I created a new column called F in the data frame. And F is a product between the two existing columns in the data frame, column A and column B. So simply the third bin is only going to contain the value 30. So both the qcat and the cat are sometimes used if you have the need of containing a number of values into either equal-sized bins or evenly spaced bins. And now let's take a look of the vector functions that can operate on all columns of a data frame or a single selected column. So first, let's take a look of the clip command. So here, consider that we create this data frame with the following values. And I used the clip command to trim the values so that if a value of a cell is lower than the lower bound, is going to be reassigned a value equals to the lower bound. Whereas if a value in a data frame is greater than the upper bound, is going to be reassigned a value of the upper bound. So here I specify the lower bound equals 5 and the upper bound equals 10. And in this case, as you can see, that 4 is lower than the lower bound of 5, so it's replaced by a value of 5. And 28 is greater than the upper bound of 10, so it's reassigned a value of 10. So in this case, you can use the clip command to shrink the variation in your data frame so that the data frame can be restricted to a smaller range. And optionally, besides using the apply command to do operations by rows or by columns of a data frame, you can also use the transform command. So the transform command works very similarly as the apply command, but there are some minor differences. So if you're interested in the differences between transform command and apply command, you are welcome to take a look of the link here, but we are not going to into details of the differences between the transform and apply command here. And now let's take a look of the very important group or aggregate functions in Pandas. So here we created a data frame called animal speed. And it has two columns. The first column are animal names, and as you can see, there are two animal types, falcon or parrot. And the second column are the speed, the flying speed of the animal. So say the first falcon has a flying speed of 380 miles per hour. The second falcon has a speed of 370 miles per hour. And the first parrot has a flying speed of 24 miles per hour, and the second parrot has a speed of 26 miles per hour. And if you print the data frame looks like this. So here, presumably, we want to do some aggregate functions by animal species. Basically, so for example, we can calculate the mean speed of falcon and the mean speed for parrot, how we can do that. So first we need to use the group by command to group the data frame by a specific column. So here we provide the argument by equals animal so that we can create a group by object so that the data frame is grouped by the animal species, basically by falcon and parrot. And after group by, you can do the mathematical operations based on the species. So here I want to calculate the mean flying speed by animal. So for example, here the resulting data frame take only two rows. The first row pertaining to the flying speed of a falcon, the mean speed of the falcon, which is 375, which is the mean of 380 and 370. And the mean speed for parrot is 25, which is the average of 26 and 24. You can also calculate the maximum, minimum speed by animal species as well. And you can also count the number of non-missing values by animal species. And you may notice that I use the as index equals false argument because by default, the as index argument equals true, so that if you use the group by command, the group by command is going to replace the generic index by the animal species. So basically, the 0 index is going to be replaced by falcon, and the 1 index is going to be replaced by parrot. Well, you may want to do that or don't want to do that. So here I do not want to replace the genetic index by the animal name so that I specify as index equals false. The second way to do the aggregation is to use the AGG, or standing for aggregate command. So the aggregate command take a little bit more effort or complication in comparison to directly using a built-in function. But there are two advantages of using the AGG command. One is that you can provide more than one function to different column. So for example, imagine that you have, besides speed, you also have no other columns that you want to calculate a median or a standard deviation. You can specify in the AGG command using a dictionary. So here, I want to calculate the mean for the speed, but well, you can also expand the dictionary by provide additional key value pair so that you can do other mathematical operations on other columns in the same run. The second advantage of using the AGG command is that you can provide self-written function, so you won't have to use a built-in function. So let me illustrate that. So here I provide a self-written function. Is a simple lambda function of max x minus min x, basically the difference between the highest flying speed minus the difference minus the minimum flying speed by an animal species. So for example, here the resulting data frame look like this. The 10 comes from the difference between the maximum flying speed of falcon, which is 380, minus the minimum flying speed of falcon, which is 370. And 2 come from the difference between the maximum flying speed of a parrot, which is 26, minus the minimum flying speed of a parrot, which is 24. You can also use the built-in function size to get the size of each group, which do not count for the missing values. And as you can see that the resulting data frame, the size for falcon is 2 because there are 2 net missing values for falcon. Also, there are 2 net missing values for parrot. You can also use the transform function following the group by object. So using the transform function with group by is going to create a column in the data frame that has the subgroup means in it. And the resulting data frame would have the same dimension as the original data frame. So let me illustrate this idea. So here I create a new column in the animal speed data frame called mean speed. And then I use the group by function. I group the animal speed data frame by the animal species. And I want to calculate the mean for the column speed. And so the resulting data frame look like this. We still have the 4 rows as in the original data frame, but we are adding an additional column called mean speed. And in the mean speed, we have the average speed for falcon and also the average speed for parrot. And sometimes there is, it is useful to shift the data either down or up by a step based on the grouping. We can use the shift command to do that. So first we group the data frame animal speed by animal species. And then we specify shift 1. Shift 1 is going to shift the group one step down by each animal species. So for example, here, shifting down means that we are going to replace the second value for the speed of falcon by the speed of the first falcon. So 370 is going to be replaced by 380, whereas because we do not have any values preceding to this observation, so the 380 is going to be replaced by a null value here. And by the same token, in the parrot category, the 26 is going to be replaced by 24, whereas the 24, because there's no preceding values pertaining to parrot, so therefore the corresponding value is going to be missing. And by the same token, we can also shift up one step using the shift -1 option. And it works exactly the same way, but we are shifting one up so that we are replacing 380 by 370, and 24 is going to be replaced by 26. Sometimes we want to rank the variables, the group by object. There are two ways we can rank based on how we deal with the ties. So let me illustrate this idea. Here we are still using the same data frame with falcon and parrot, and we group by the animal species, and then we use rank method mean. Rank just means that you are is going to associate a higher rank for a larger number and a lower rank for a smaller number. So therefore, because 380 is larger than 360, it is 370. So therefore, it assigns a rank of 2 to the first observation, and rank 1 to the second observation. And here, because 26 is greater than 24, so therefore it's going to assign 1 to the first observation pertaining to parrot, and 2 to the second observation pertaining to the parrot. And the difference between the method equals mean and method equals max is how we deal with the ties. So for method equals max, the record that have the same values are ranked using the highest rank. And say, for example, if A and B are both in the 5th and 6th position, and then rank 6 is assigned. For method equals mean, the record that have the same values are ranked using the lowest rank. So for example, if both A and B are in the 5th and 6th position, and then rank 5 is assigned. We can also calculate the sum, the cumulative sum, the cumulative maximum, cumulative minimum, and cumulative product by using the group by object. For example, to calculate the cumulative sum for by animal species, because the first falcon has a flying speed of 380, and the second falcon has a flying speed of 370, so that for the second observation, the sum will not be calculated as well. So you get a non-value here. Now let's illustrate very briefly how you can use Pandas to do some basic plotting. So here we created a data frame. It takes 3 rows A, B, and C, and also with indexes. And we want to plot a histogram for the column A. And we can quickly do that by just calling the column A of the data frame and then use the plot function. And in the plot function, we specify kite equals hist, denoting that we are going to plot a histogram. And as you can see, the histogram is created for you. It is very handy because it takes really minimal effort to create a figure using the Pandas built-in function plot. You can also do other type of plots using the plot function. For example, here I want to create a scatter plot. I still use the plot function. I only need to change the argument kite to scatter. And then I need to provide the 2 additional arguments because the scatter plot needs the value for x and for y. So x, we assign the column A to x and column B for y so that a scatter plot is produced for you. And now let's take a look at how you can combine data frames together, basically merging 2 data frames. So here we created 2 data frames, ADF and BDF. It takes the following value. So as you notice that ADF have 2 columns, x1 and x2, and BDF take 2 columns, x1 and x3. So also, you notice that for the first data frame, the x1 take 3 values, A, B, and C, whereas in the second data frame, the x1 take 3 values, A, B, and D. So therefore, only the A and B values in x1 are shared between these 2 data frames, whereas the third column, C and D, they are not shared between the 2 data frames. So that illustrates how you can merge 2 data sets together. There are a few ways you can merge depending on your need. You use the merge function, and then you provide the 2 data frames. Notice here we provide ADF to the left and BDF to the right. So that here we specify you are going to do the left merging. So you specify how equals left, meaning that you are going to fix a ADF to your left, and then you are going to merge BDF to ADF. And then you also need to specify based on what column you are going to do the merge. And because the only shared column is x1, so I'm going to use x1 to do the merge. So as you can see, the resulting data frame look like this. You have 3 columns, x1, x2, and x3. And if you take a look at the value, x1 and x2, they take all the values from the left data frame, which is ADF, whereas for x3, it takes the value from the second data frame, the BDF from the right. And but while there's one missing value here for x3, the reason is because only the value A and B in x1 can be merged for the two data frame, whereas there's no value C in x1 in the data frame BDF. So therefore, the Pandas does not know how to assign the value x3 for that row. So therefore, it left with a missing value for x3. And besides the left join, you can also do an inner join. So inner join just means that you are only going to retain the rows that are shared by both sets. So if there's missing value based on merging, that entire row is going to be least divided, least removed. So here, for example, if you do the inner merging, you only have 2 rows instead of 3 rows because here the x3 has a missing value, so that entire row is dropped by the inner merging. You can also do the outer merging, which works the opposite as the inner merging, so that you retain most data, regardless of whether the merging result in missing values or not. So in this case, if we do the outer merging, you will see that we retain both rows. Despite that, we have a missing value for x3 for x3 column. Also, we have a missing value for x2 in this column. So regardless, we retain both rows with missing values in the merged data frame. We can also do the filtering join using the isin command. So in this case, we want to first test whether the column x1 values in the data frame ADF is within the values of column x1 in the BDF. If this satisfies this condition hold, we are going to retain the corresponding rows and columns for ADF. And we can also do the opposite of filtering join. So we are only going to retain the rows and columns for ADF if this condition is not hold. So the way we can do that is to use this tilt symbol to denoting opposite or not. So it means that, and we can also iterate a data frame, so that illustrate how we can do that. So here we create a data frame with the two, for example, two people from two states, and we also have the state name, and also we have the point. And the indexes are the name of these two individuals, Alice and Bob. So you will see the data frame created like this. For Alice, you have the age 20, residing state in NY, and point of 64. And Bob, you have age 32, residing in CA, California, and point of 92. And to iterate the data frame row by row, you can simply use the iterRows command. So when you use the iterRows, it's going to values in that row at the same time. So you can iterate the data frame using iterRows in a for loop. So in the for loop, you specify for, and then you provide the row index and then item, so that you can, for example, print the row index to take a look, and also the corresponding item denoting the values of that row. So in this case, if you print the row index, remember the row index are the people's names, then you're going to print the Alice in the first row and Bob in the second row. And if you print the item would just be the values corresponding to that row. So you've got the values for all three columns pertaining to that row. So that concludes a brief introduction to Pandas.